Welcome back to Hidden in the Stars. In this episode, we are looking at the Parker Solar Probe, which launched on August 12, 2018, named for American solar and plasma physicist Dr. Eugene Parker. It was the first NASA spacecraft named for a living scientist, according to NASA. Its mission? To boldly go where no man has. Wait a minute. Scratch that. Let me try again. The mission of the Parker Solar Probe is to approach the Sun to trace the flow of energy, to study the heating of the solar corona, and to explore what accelerates the solar wind. According to NASA, the probe's mission will provide answers to long standing questions that have puzzled scientists for more than 60 years. Why is the corona much hotter than the Sun's surface? How does the solar wind accelerate? What are the sources of high energy solar particles? The answers to these questions will help scientists better understand the Sun's impact on Earth. The data will be key to understanding and, perhaps, forecasting space weather. As we saw in our episode on the Carrington event, which I will leave linked, space weather can change the orbits of satellites, shorten their lifetimes, or interfere with onboard electronics, with potentially devastating effects for our common technological devices. The Parker Solar Probe can survive the Sun's harsh conditions because of thermal engineering advances that protect the spacecraft, to the point of making autonomous adjustments to its positioning. The object is protected by a hexagonal solar shield measuring 2.3 meters in diameter and nearly 12 centimeters thick, with a white reflective alumina surface to minimize absorption. The probe has 4 instrument suites designed to study magnetic fields, plasma and energetic particles, and image the solar wind. The Fields instrument suite captures the scale and shape of electric and magnetic fields in the Sun's atmosphere. The ISIS, Integrated Science Investigation of the Sun, instrument panel uses 2 complementary instruments to measure particles across a wide range of energies. By measuring electrons, protons, and ions, ISIS will understand the particles' life cycles, where they came from, how they became accelerated, and how they move out from the Sun through interplanetary space. Next comes the SWEEP, solar wind electrons, alphas, and protons. This investigation will count the electrons, protons, and helium ions and measure their properties such as velocity, density, and temperature. Finally, there is WHISPER, Wide Field Imager for Solar Probe. These optical telescopes acquire images of the corona and inner heliosphere. This fascinating photo from the WHISPER on November 8, 2018, shows a coronal streamer with at least 2 rays visible. Parker Solar Probe was about 16.9 million miles, or 21.2 million kilometers, from the Sun's surface when this image was taken. The bright object near the center of the image is Mercury, and the dark spots are a result of background correction. This next WHISPER image from June 7, 2020, captures the first 6 planets in our solar system. So how does it move? According to Kepler's laws of planetary motion, gravity will cause the spacecraft to accelerate as it nears perihelion, then slow down again afterward until it reaches its aphelion. Because of the Sun's strong gravity, this effect is particularly pronounced for the Parker Solar Probe and can be seen on this model. Notice that the speed of the probe increases as it approaches the Sun and slows down as it nears Venus. If you look closely, you will also see that the probe is passing closer and closer to the Sun each time as its orbit becomes more and more elliptical. Parker Solar Probe completed its 24th close approach to the Sun on Thursday, June 19, 2025, again achieving its record distance and speed records previously set on December 24, 2024, and March 22, 2025. At perihelion, the probe measured a distance of 3.8 million miles, 6.2 million kilometers from the solar surface, and a speed of 430,000 miles per hour, 687,000 kilometers per hour, a speed fast enough to fly from New York City to Tokyo in less than a minute. Unfortunately, Parker Solar Probe is on its final flyby. It is now inside the orbit of Venus and will no longer receive the gravity assist from that planet. It will remain in orbit for some time, occasionally relying on its thrusters to adjust its course. Eventually, however, the thrusters will run out of fuel, at which point scientists will rotate the probe so that its underside is exposed to the sun, which will be burned away, leaving only its solar shield to continue to orbit for potentially millions of years. So, what do you think? Do you think that the information from the Parker Solar Probe will enable scientists to make better predictions about space weather? What else would you like this spacecraft to accomplish? As always, we are interested in reading your thoughts in the comments section. Do you have a topic that you would like us to examine? Thank you for joining us on our journey to discover what might be hidden in the stars.